Hello and welcome to today's webinar on cybersecurity for off-highway machines. My name is Jan and I welcome you on behalf of ITK Engineering to today's webinar. Such a great pleasure to have so many participants today with us, and I'm really looking forward to present you in the next hour our portfolio with respect to cybersecurity, and especially the topic how to start and what to go next in that context. Well, 10 years ago, I probably wouldn't have thought that I will stay here and talk to you about cybersecurity for off-highway machinery. Back then, in fact, we had already the first projects with respect to cybersecurity at ITK. 5 years ago, when I joined ITK, it became a bit more prominent in the field of agriculture. For instance, we were in a project for the Agricultural Electronics Foundation, where we were securing the communication between the implement and the tractor. So you could already see there is a topic. And now with the advent of NIS2 and Cyber Resilience Act, which we will introduce shortly in the next couple of minutes, the relevance of cybersecurity got more and more. This being said, I'm so happy to see so many participants joining, and I would like to show you now on the next slide our agenda for today. So I will briefly introduce you to off-highway engineering at ITK. Who is ITK? What are we doing? And what are we doing in the field of off-highway engineering? And then pass over to our referents, Jens and Milan, who will then guide you through the webinar. In that context, we will start with the why. Always an important question. If you have a new topic, you want to understand why you are doing that. And obviously also you want to explain that to the colleagues of you who might not have listened to that webinar, but of course with whom you can share the link to the record. At the next step, we will then dive into the cybersecurity regulations, NIS2, and also Cyber Resilience Act, to which I was just referring to. Then Jens is going to explain how standards and norms help us and you in order to comply with the cybersecurity regulations. And then we have all the stage set, and we will introduce you how to become ready, what to start with, followed by a showcase how to start with a TARA. If you might not know yet what a TARA is, no worries. Milan is going to explain that very well in a sec. And then last but not least, or kind of last but not least, every good presentation has to come to an end. Within the conclusion and outlook session, we will summarize today's webinar, and then obviously, as I already referred to, look forward to the question and answer session. So on the next slide, you see our portfolio. Of course, I could talk quite a lot about that. In fact, I would like to keep it short and summarize it in 3 sentences. With 1,300 employees working in 15 different locations for more than 30 years, we are very happy to support our partners with systems and software engineering. We belong since 2017 to Robert Bosch, and you can see our headquarters on the top right and our management on the top left. On the next slide, you see the different industries where we are active. Of course, automotive is the strongest, with more than 60% of our turnover, but we as off-highway vehicle team benefit from that quite great. Why? As I was just referring to at the beginning, in 2014, we had our first cybersecurity project, and nowadays we are more than 50 security engineers working in that field. Of course, seeing that cybersecurity is a relevant topic increasing in the field of off-highway vehicles, we would be happy if all 50 employees would work in that context. However, as you might know, it's not so big, and therefore, obviously, we benefit greatly from the fact that our engineers get their knowledge from the field of automotive and can transfer that in the field of off-highway vehicles. On the next slide, you see our portfolio with respect to off-highway vehicles. In that context, we have 6 pillars: software and systems engineering, functional safety, cybersecurity, automation, connectivity, and electrification. We have very detailed knowledge in all of them, but I think our greatest strength, and this is what our partners say quite often to us, is that we can bring these different disciplines together, like, for instance, the field of cybersecurity and the field of connectivity. This being said, I would like to introduce you to Jens and Milan, who will in the following section tell more about cybersecurity. It's such a great pleasure to have you here with us, Milan and Jens, and I'm looking forward to what you're going to say. Let me just shortly introduce you. Jens has done a PhD in cybersecurity and is one of our founding fathers of cybersecurity. So great to have you with us, Jens. And Milan has done also a PhD in cybersecurity and works since 2.5 years now with us. This being said, Jens, the floor is yours.
Thanks a lot, Jan. So as you put earlier, before we talk about cybersecurity, we have to talk about why cybersecurity at all. And certainly one side of the medal is that our systems become more and more connected. That is something that is not only happening in the off-highway vehicles industry, but also in automotive and in other industries. And it leads to something that is less pleasant, and that is that attackers have a bigger attack surface in the end. So they have a bigger chance to compromise our systems and induce damages for us, like reputation losses. They can impact our customers' safety and privacy, maybe. They can steal our intellectual property, and this leads to financial losses, and the list goes on. This is also recognized by regulators, such as the European Union, that try to address this problem by issuing regulations in this regard. And there are two prominent regulations there that might also affect you as off-highway vehicle industry manufacturers. And the one of them is the Cyber Resilience Act, which affects manufacturers of products. So the goal here is to protect the EU market against cheap and insecure products. That is the goal of this regulation. And on the other side, we have the EU NIS2 directive, which is targeted at system operators. So not the manufacturers of systems, but the ones that actually operate these systems and put them to use. And the goal here is to protect essential and important system operators in the EU, to protect our society against attackers and malicious persons, also stateside actors. So the conclusion of the slide basically is, well, why cybersecurity? Because cybersecurity is an enabler for future connected product features and business models. It is required to put products in the market in the European Union, and as such, it has to be considered an enabler. It's no longer optional. So now let's briefly look into this. How do these regulations look like, and where do they apply? For this, I draw a small map chart, basically, that divides the world in two pieces. The one piece is IT, information technology. That includes everything from the IT of your engineering, of your sales, of the laptops that you're probably currently watching the stream, over backend systems like your cloud infrastructure, your web services, but also diagnostic laptops that are used to diagnose your systems out in the field. And the focus here is more on information and data security than it maybe is on the correct function of things. Of course, that's also an issue, but the focus here is on information security. On the operational side of things, so for operational technology and the OT world, the focus is the correct function. So we don't want our systems to misbehave in a certain way. We need them to function. We need them to be resilient against attacks. And here there are things included like the machines that you're probably selling to your customers, but also manufacturing machinery, like the manufacturing lines in your factories, logistics systems, and so on and so forth. And now the two regulations I mentioned earlier, the NIS2 directive, as I said, is mainly targeting operators of systems. So this would affect your cloud infrastructure, your backend services, but also your IT systems, your laptops, and so on. But also the operational technology, like your factories, your logistics, everything is included there. In the sectors that are affected by this, I will come to this on the next slide. On the other hand, the Cyber Resilience Act is affecting your products. So the machines that you are selling to your customers, but also things like the diagnostic laptops that your customers are using to diagnose their equipment, or the workshops are using. So now let's have a deeper look into that. What is the NIST directive all about and who is affected? Not every company is affected, that I have to say up front, but only companies who operate essential and important IT and OT systems. So what does this mean? It depends on the sector that you're active in. So sectors that are essential for society, for instance, energy, transport, health, digital infrastructures, and so on, they are essential sectors. But there are also important sectors that are not as critical, but that still fall under the NIS2 directive. And here things are included like manufacturing, digital providers, production, processing, and distribution of food, for instance. And if we have a deeper look into that, for instance, in manufacturing and kind of research, what do they mean by that? They reference the NACE categorization. And here it says, well, companies that manufacture lifting and handling equipment are affected, manufacturing of agriculture and forestry machinery is affected, and manufacturing of machinery for mining, quarrying, and construction is affected and is considered an important sector. You also see there is a small asterisk here that says a size cap rule applies. So if you are a really small company with less than 50 employees, or I think around 10 million turnover, less than 10 million turnover, then you are not, you're not affected by NIS2, even if you are in such a sector. But if that's not the case, then you have to look deeper into this topic. Jumping over to the Cyber Resilience Act, here who's affected? Basically not the operator of systems, but the manufacturer and the distributor and importers of products with digital elements. Translated, this means products that have software in it and that have a direct or indirect data connection to another device. So if your device or if your product has an interface like a Wi-Fi connection, a CAN bus connection, Ethernet connection, or even a USB port, you are probably affected by the CRA. Sectors that are affected, here the distinction is not made based on essential and important sectors, but every sector out there is affected if it is not regulated in any other way. So for instance, medical devices or road vehicles, they are not affected by the CRA because they have already their own regulation in place. But everything that is not regulated otherwise, can be a smart fridge, but can also be a tractor or a harvester, is affected by CRA. And yeah, there are also penalties that apply up to 15 million euros or 2.5% of the annual turnover, and potential product recalls. And the penalties are fairly similar to the NIS2 directive, where it's up to 10 million euros or 2% of annual turnovers. But with the NIS2, also personal liability of management is mentioned in the directive. So it's basically a task for the CEO. He has to take care of that in order to avoid personal liability. Okay, the focus of this talk will be about the Cyber Resilience Act because it's closer to the products that we are selling in the off-highway vehicle industry. So now let's have a deeper look into what does it even mean? Yeah, what does the CRA require? And well, it requires basically that you're doing security engineering right. You have to consider cybersecurity in the planning, in the design, in development and testing, production, delivery, and operation and maintenance of your product. And a central role plays the topic of cybersecurity risk assessment, which Milan will talk about later, which basically is about determining which risks are there for your product and making decisions on which risks have to be handled, have to be mitigated, and which risks can be accepted with a rationale. And this includes not only your own risks, but also risks that you are kind of buying in when you're sourcing certain components of your system from suppliers. Another thing that is requested are easy to understand usage instruction for your users, but also a machine-readable software bill of material. That is basically a list of ingredients, a list of software packages that you or your supplier your suppliers used to build the product. And why is this necessary? Well, another obligation that the CRA imposes is that you have to perform vulnerability handling, meaning once the product is in the market, once the product is sold and the customer uses it, you have to, for a reasonably expected product lifetime, monitor the product and the ingredients whether any new vulnerabilities are discovered. Right? So vulnerabilities are discovered over time. They are typically not all known during the engineering phase, but could also be detected during the in-field phase of the product when it's out there in the field. And you have to take care that you notice that and scan your software bill of materials for vulnerabilities continuously, and also perform mitigations and security updates if there are some critical vulnerabilities that needs to be fixed. And maybe one more word to this reasonably expected product lifetime. This is not something that you can freely choose. So for instance, you cannot simply say for a product, the product support period is 2 years. If your customers expect the product to run for 20 years, then you have to, well, it's a bit more complicated than that, but essentially you have to provide software updates for a longer time than you might think. And also, on the other side, we have exploit and incident reporting obligations, meaning that if something happens with your products, if there are some important or critical incidents, you cannot keep this to yourself, but you have to report them to the National Cybersecurity Emergency Response Team and the NISA, which is the entity on a European level that takes care of this. So there are also reporting obligations. Now, what is the timeline for these regulations? How much time do we have to actually follow them? The good news is that the Cyber Resilience Act has not entered into force yet. The European Parliament voted already on it. It passed with a huge majority, and the European Council still has to approve it. It is expected that this happens in the end of 2024, but from then on, we have a transition period of to be fully compliant of 36 months. So for products that are put on the market after end of 2027, we have to be fully compliant. We have to do everything I showed you on the last slide. If you put a product in the market before that, the old rules still apply, with one exception. The incident reporting obligations, they become mandatory from mid of 2026. Meaning that also for legacy products, if something happens with your products, you have the obligation to tell the CSIRT and the NISA about it. And potentially also take action if they tell you to. On the NIS2 side of things, the NIS2 directive is already decided, but it is a directive, so it has to be put into national law. It's not a regulation like the Cyber Resilience Act. And the deadline for this is basically October this year. So every European member state has to put this into national law by October, and there are no designated transition periods. So theoretically, you have to be compliant already from October onwards. So now one slide about standards and norms. So these are regulations. So if you read regulations, you know that the level is fairly abstract, and typically there are some standards and norms to kind of tell you what to do. And for the CRA, it covers a lot of industries. It's not only of highway vehicles, it's also IoT industry and other domains. So there is no one standard that implements that. However, there are some standards out there, like for road vehicles, the ISO 21434, that is currently used as a basis by the agriculture industry to draft their own standard, which heavily relies on the content of this one, which can be used to actually have a foundation to be CRA compliant in the end. At least that is the goal. So now, how can we become ready? How can we take action now that we know what is coming in the next 3 years? And we are currently consulting a lot of customers on that, and we have some lessons learned that we want to share in this webinar also for you. So what you typically can do is a top-down approach, right? We know that the obligations that I showed you, they go a bit beyond the mere engineering of things. So it's not just about secure engineering, but also about continuous activities like vulnerability monitoring, incident management, that you can actually report incidents, handling suppliers and determining risks of suppliers, and also having processes around that so that you can make sure that you are actually doing these things. And the top-down approach is the typical consultant approach, right? You look at external factors like regulations, customer requirements, market demand, and your own risks, and determine strategic goals based on that. Then you do a gap analysis, look at what is already there in the organization, and identify where fixes are needed, and then determine key activities that are needed to drive the change. That is the typical consulting approach. It has its advantages, but it also has disadvantages, like it takes a long time until you see some value, right? Until something actually ends up in the product. And that's why there's another approach to do this bottom up, which is a more pragmatic approach to say, well, we look at a specific product and we just start doing a risk analysis. So a TARA, a threat and risk analysis for that, and take it from there, right? Take it iteratively from there, determine the risks, decide on which risks need to be treated, and treat the risks in the concept, in the security concept, develop the system, test the system, and once it's in the field, we do the vulnerability monitoring and management and incident management. And the advantage of this is, of course, you see what you pay for, right? You have it right in your product, and you have the artifacts, the security artifacts that you need in your hand pretty soon. However, it is also slow in the regard that if you have multiple products, this doesn't scale well, because you take it one step at a time, and with a timeline of 3 years, it's probably already a little too late for most companies to do this for their entire portfolio. So that is why we also have a third option to tackle this, and that is a hybrid approach. And we say, okay, we start from the top, but also from the bottom. So we determine which processes need to be adapted, which guidelines need to be adapted, but we are not only working on the theoretical part of things, but at the same time, we do a co-engineering and start implementing the things based on an actual product. So we are doing a risk analysis based on the risk guideline that we put out there, for instance, and make sure that ends meet and the things actually work together. Now, I'm aware that this is probably also too much, especially if you are a small company, and there are different pragmatic approaches needed, which is why currently we are working on a CRA workbook that is targeted at smaller companies and contains templates for the threat and risk analysis, templates for the concept, to get you basically a kickstart into the topic and give you something to actually work your way through it. There are also some information and ideas on how vulnerability management and incident management can be handled and so on. That is something we currently work on. If you're interested in that, please contact Jan. He's happy to assist you there and answer your questions regarding this. So my last slide before I hand over to Milan is our portfolio slide, but I won't talk much about our portfolio, but more about the cybersecurity engineering process to give you an overview what is behind that. And it typically starts with a risk assessment, where we determine what does security actually mean for my product. Which risks are there? Which risks can I accept? And which risks do I have to mitigate with security mechanisms in order to get security into my product? And in the concept, then we think about, well, which security mechanisms do we have to put in place to address these risks? Then we have to think about how to implement the security measures securely. And finally, we have to think about how can we test that we did everything right. especially when it comes to penetration testing. We try to hack the system. We try to simulate a hack. But the thing starts with the risk assessment, and that is where I hand over to Milan, and he will tell you a little bit more about how to tackle risk assessment, and he will also show you that it pretty much depends on your company again, which approach is the right fit for you, right? Because it depends how big your company is, how many products you have, whether the Excel sheet is the right way or the fully automated solution is the right way. So yeah, I hand over to you, Milan. You are still muted.
Thank you, Jens. So we're live. Of course, these things happen. All right. Thank you, Jens, so much for the nice introduction on the CRA and also the security engineering process. And yeah, in the second part of this webinar, I want to talk a bit about the TARA, the threat analysis and risk assessment in system and product development. And I will talk about why we want to do it, and I will also talk a bit how you can actually do it in practice. So why do we want to do a TARA? Jens already spoiled it more or less. So there's essentially two reasons. The first reason is that we want to be able to talk about risks, right? We want to make specific what kind of risks are in the product. And then in the second step, be able to make informed decisions about how to treat each of these risks. So it's a management tool that translates from management to the engineering. And what I've shown you, or what I'm showing here on the slide, is a risk matrix, an example of a risk matrix that is a common way to visualize the result of such a TARA. And the risk matrix has two dimensions. We have as one dimension on the y-axis, as you can see, the attack feasibility rating, in which we try to explain how hard or how easy it would be to realize a certain attack. So how much effort does an attacker need to put in? How much investment does an attacker need to put in to realize a specific attack? So things might be rather easy, and if you need to have a lot of expertise, a lot of equipment or specialized equipment, for example, then the attack feasibility will go down a bit. But a TARA does not make sense by only looking at the attack feasibility rating, but we also need to have a look at the impact. So with the impact rating on the x-axis, we are trying to describe the real-world effect that a successful attack would have on any stakeholder of the system, right? And we can talk about different categories of impact. We can talk about safety impact, so where human lives might be threatened or human health might be threatened. We can talk about operational impact, so something becoming unavailable or not functioning properly, disturbing maybe the business. We can talk about privacy impact, so basically some data being leaked, and so on and so forth. And so these two dimensions together are basically forming the risk matrix. And in the next step, we can take each of these cells from the matrix and map it or give it them a risk level. And in this example here, I've shown 5 different risk levels that are color-coded so that you can immediately see sort of what is the most critical, what is the lowest risk. And in this matrix here, in the upper right corner, you can see the risks that are very easy to realize and have the highest impact. And so those are the most critical risks. On the other end, on the opposite end of the risk matrix, we have the risks that are very hard to realize and might only have a very small impact. And you can immediately see that if we sort of map our risks into this matrix, we can derive a prioritization regarding the risks that we need to address. So we might want to start with the risks that are most critical and then work our way down to the lower to the risk with the lower ratings. This might be a bit abstract for now, so I've brought with me 2 examples of what such a risk could look like. And one example risk could be that an attacker is able to jam the wireless channel, and with that is able to disrupt an ongoing platooning operation. So in this example, we're assuming that there's some machines that are cooperating and performing a platooning operation, and they're communicating via some wireless interface, maybe Wi-Fi or something else. And then the risk expresses the case where an attacker just gets close by to the machinery, installs a jammer, and basically disrupts this platooning operation. And regarding the rating, we might say that performing such a jamming attack is rather easy, doesn't require a lot of skill. There's tools out there that can facilitate this. So we might say that the attack feasibility is rather high. On the other hand, the impact could be rather low if we are considering that an operator would be able to recognize that an attack is ongoing and might be able to intervene manually. So the operational impact in that case might be rather low, depending on the use case. As another example, we can think about the scenario where an attacker steals a machine, steals a tractor, and from this stolen tractor is able to extract some cryptographic keys, some credentials, some user credentials, and with these credentials is able to access the operator's backend system. And here we might say the attack feasibility is a bit lower because you actually need to have physical access to the machine. You need to be able to steal it. So it's maybe a bit harder because you can be detected to do something like that. On the other hand, the impact might be much higher. Of course, that very much depends on what kind of data you might have stored on the system. So if the data is deemed to be very critical and important for the operator, the impact might be severe. So those are just 2 examples. There are, of course, many more that we've also seen in practice or that we are deriving in the TARAs that we're doing for our customers. So to sum this up, we're doing a risk analysis to talk about risk and to be able to make informed decisions about how to handle these risks. And now I want to get into a bit more detail about how to actually do such a TARA. And I have to say up front, there's different ways how to do it. And we have basically applied all of the approaches that I'm going to show you here in real customer projects. What I'm showing you here is what we have seen in industry, the different approaches. And of course, each of these approaches comes with their pros and cons. So very much depending on the use case or the scenario, you might choose one over the other. And so we don't say there's a right and a wrong approach, but there might be the fitting solution for you. And so I want to start with the, let's say, maybe the easiest approach that we call the ad hoc approach that makes use of a general purpose tool that you might have already at hand, like Microsoft Excel. And with such a tool, you can open up a spreadsheet and just starting listing down all of the risks that you might have identified during the threat modeling process. And then for each of those risks that you have identified, you can give them an attack feasibility rating, an impact rating, and then compute the risk level of your risks. So it's very easy in principle if you know what you're doing. There's a lot of the opposite. There's not a lot of upfront investment into this approach because you're using a tool that you already have at hand. So you can get started rather quickly and rather easily. The issue with this approach is it comes later. So typically you do a TARA upfront in the beginning of the project. And during development, we have seen that also the TARA needs to reflect the design changes, the architectural changes that have been made to the product. And when using such an ad hoc approach, maintaining the Tara, keeping the Tara up to date with the current design of the product becomes rather cumbersome. So maintainability is not very good. And also because you do a lot of things manually, this approach we have seen is quite error prone. And because of the shortcomings of the ad hoc approach, industry has moved towards what we call a more structured approach. And here we usually use a dedicated tool for performing a Tara. There's a number of tools out there on the market that are able to help you do this. And what these tools all have in common is that they sort of guide the analyst, guide the engineer throughout the Tara process, and sort of put the guardrails, so what you can do, what you cannot do in a Tara to prevent a bit of the errors that you might do with the ad hoc approach. These tools might also improve your consistency and efficiency of doing a Tara, because some of them allow you to model, for example, attack trees. Attack trees are a very efficient way to capture different ways that an attacker might be able to achieve a certain or realize a certain risk. So with this approach, you get better maintainability, better consistency, but of course also a bit more upfront cost. So the initial effort might be a bit higher than for the ad hoc approach, but for regular products, where we have to maintain the Tara, we have usually seen that this investment pays off in the long run. However, we have also seen that the structured approach, we have pushed the limits of the structured approach in the past in customer projects, because we have seen that this works very well for smaller products like individual ECUs, smaller systems. But if you have a look at more complex ecosystems, for example, entire vehicle with connection, backend connection, where we also have to consider the backend as part of the Tara, then this structured approach doesn't scale very well. And this is why in the past years we have been, for these types of projects at least, we have been moving towards what we call a semi-automated approach, where we think of a Tara in terms of a pipeline. We think about inputs and outputs of a pipeline. So the input might be the system design, the system architecture, and the output might be the risk matrix that we have seen before. And we try to automate as many of those steps that you do in a Tara as well as possible. And by doing so, we are greatly increasing the reusability of the Tara. We are able to scale to these more complex projects. And we also get a much better consistency between the inputs and the outputs of the Tara process. That being said, might still not be the best option for any product that you're doing a Tara for, because there's quite a bit of one-time effort that you need to invest upfront. Also setting up the pipeline and so on and so forth might be overkill for smaller projects. So this is sort of the three different ways that we have been doing Taras in customer projects. And I want to go into a bit of detail regarding one of those methods, and that's the semi-automated approach. And what we have been doing is the semi-automated approach revolves around an existing Tara tool from the structured approach that already gives you some export functionality. So you get an interface to your document management system. You need to do that because usually management need to sign off on the risks that you want to mitigate and that you want to accept. And with this semi-automated approach, we are able to implement additional workflows. So we might be able to implement variant management, which can be important if you're developing a platform product or a product that can be configured by the customer in different ways, can have a backend interface, might have a wireless interface, and so on and so forth. And by implementing variant management, we are only doing a single Tara for the entire platform, and then can compute the risks for each of these variants very efficiently. Taking this a step further, we can also think about composition, where we sort of decompose a more complex system into subcomponents that we can model all individually, then later on put them together and get the final risk analysis. And the third workflow that we have been applying in the past is probably the most powerful one, where we actually dynamically generate part of the Tara. So we might be interfacing with external input like the system model, and we actually might write code that models then part of this Tara. I want to briefly go into the composition workflow, where we want to, as I already said, model and manage more complex systems. And the good thing about this, what we're doing here is we apply a divide and conquer approach. So we take a big system, we slice it up, and then have smaller problems that we can work on. And the benefit of doing this is that we can start with a Tara for a single component. And then as we're doing this, we might be able to add Taras for more components that are together building this more complex system. So this is a good candidate of also applying this bottom-up approach that Jens talked about earlier. So we can start small and move towards a more complex system. What we also need to do when applying this approach, this workflow, we also define the boundaries and interfaces between the components very much in the same way that the components influence each other. So you might think of the backend system and the vehicle, and if there's a compromise of the backend, that might have an impact or might influence the security of the vehicle because they're connected. And these are the things that we then also model in the Tara. There's additional benefits here that you can see on the slides that I don't want to go into much more detail now. I just want to show you a very quick example of how this could look like. So assuming you want to build a Tara for an entire system, might identify different component types in your system. Your system might consist of ECUs and CAN buses. You can create such Tara templates for each of those types. Then you can instantiate them in different variants. So different ECUs might have different features. Then you plug them together, maybe add additional artifacts that model the risks and the threats coming from the backend system. And then you put this all together and get your system level Tara. As I mentioned, this gives you quite a number of benefits. First of all, with the automation, we get near zero cost updates on input changes. What does this mean? As I said in the beginning, or as I said for the semi-automated approach, if your architecture, if your system design changes, you can push it into the pipeline and get an updated view of your risks. And thereby, we get very efficient management of the Tara throughout the entire life cycle of the product. So during the entire development phase, but also later when the product is out there in the field. And finally, it also allows you to integrate with other processes and tools that you might have already be using, such as a requirements engineering tool, where you can push the results from the Tara directly into your requirements engineering tool. All right. This already brings me to the end of the showcase part of the webinar, and also at the near end of the webinar presentation overall. I just wanted to show you the key takeaways that we want you to remember after this webinar. So Jens mentioned that the Cyber Resilience Act will become mandatory for products in the off-highway vehicle industry very soon, and that penalties for non-conformance will apply from 27 onward. If you want to become compliant, some of the challenges that you might face are regarding establishing a functioning security engineering process, where you have to apply these different steps from Tara, concept development, testing, production, operation, and so on and so forth, and also produce the relevant artifacts for each of those steps in the process. You will need to implement working vulnerability handling management over the entire product lifetime. So Jens mentioned this. Depending on the product type, this might be easily more than 2 years. You will also need to establish a cybersecurity mindset on the company level. Yeah, so these were sort of the challenges. But if you're able to do this efficiently and effectively, that might become a competitive advantage in the future. So if you have not already started on this topic yet, Jens has shown you different approaches and how to do it. So you can apply a top-down approach where you start with the gap analysis, where you look at what sort of the requirements are and what is missing on a company level. Or you can start bottom up by starting to implement parts of the security engineering process. For example, performing a TARA for some pilot products. And of course, you can also combine them, and then you have the hybrid approach that Jens talked about earlier. All right, and this brings me to the end of the webinar presentation.
I would like to thank you all for participating. I would like to give a big thank you to the team at ITK who enabled us to present this webinar today. Special thanks, of course, to Jens and Milan for presenting. Jens and Milan mentioned it multiple times. We had multiple different topics, different perspectives. Jens mentioned the security workbook. Milan was looking on the how to automate TARA. So I think we had for every participant at different steps where you are in your organization something interesting. And we would love to continue that discussion, not only on the EU Data Act, but of course also on the cybersecurity topics which we discussed today. So please get in contact with us at that point. We are looking forward. Give us a feedback how you liked it. Let us know. And we are here to support you. Thank you.